Final video for this chapter is going to be on average and instantaneous acceleration, which covers the material in chapter 2-8. So acceleration is the rate the velocity is changing. So velocity, remember, is the rate that the position is changing, and acceleration is then the rate that the velocity is changing. So we define average acceleration. And again, acceleration has a direction, more on that in just a second. So we're going to use A for acceleration. The arrow indicates that it's a vector, so it has a direction. We have a little subscript AV to indicate it's an average, and remember the X means that we're just dealing with one-dimensional quantities at the moment. So, and average acceleration is the change in velocity in some time interval. So delta V, delta T. So, and remember, this is the x part of v since we're just in one dimension, so that's why we can also write this with a little I hat, where I hat is our unit vector in the x direction. But the important thing, it's the change in velocity in some time interval. So the way we calculate this, so we find the velocity, the final velocity, or the velocity at t final, so that this is the final velocity. We subtract the initial velocity, or the velocity at ti, t initial. So final velocity minus the initial velocity, and we divide by the time that took. So final time minus the initial time. So just like we went from average velocity to instantaneous velocity, we can go from average acceleration to instantaneous acceleration. So again, we've got our delta V, delta T. So we start with our average acceleration, and you imagine just taking this delta T, this time interval, and shrinking it down to 0. So we take the limit as delta T goes to 0. And so this is limit delta t goes to 0 of, sorry, these should be deltas, delta v over delta t, which again, just like for velocity, so this is just the definition of a derivative. So dv dt. Now SI units, well, this is going to be, so our velocity, remember, has SI units of meters per second. Time is in seconds. So the SI units for acceleration are going to be meters per second, or another way to write that is a meter per second squared. But it's actually not, it's useful to think of it as a meter per second, because let's say you have an acceleration of 1 meter per second, that means the velocity is increasing by 1 meter per second every second. So let's say you start off at rest, so your velocity is 0. So after 1 second, you're going to have a velocity of 1 meter per second. After another second, so after 2 seconds, you're going to have a velocity of 2 meters per second. After 3 seconds, you're going to be at 3 meters per second, and so on. So every second, your speed is changing by 1 meter per second. Okay, now the other thing, remember, velocity is a vector, so it has a direction. And in particular, something that's sometimes a bit confusing, so in physics, we always use the term acceleration. Now, you also commonly hear deceleration. And deceleration commonly means slowing down. But usually in physics, we just talk about acceleration, and acceleration just means the velocity is changing. So it could be speeding up, it could be slowing down, it could be changing direction. And all of those things we just call acceleration. And in particular, a trap you don't want to fall into is don't fall into the trap of thinking if the acceleration is positive, that means you're speeding up, because that's not what it means. Because when it comes to speeding up or slowing down, what actually matters is the relative direction of acceleration and velocity. So if your velocity and your acceleration are in the same direction, so if they're both positive, or if they're both negative, then you'll be speeding up. But if they're in opposite directions, you'll be slowing down. So if the velocity is positive and the acceleration is negative, or the velocity is negative and the acceleration is positive, you'll be slowing down.